So welcome everybody to our CCNP class Encore. Today, what I want to do is just hit a topic to make sure you're aware of it and don't get caught off guard, because I think one of the things I'm doing is I'm continuing to study for my CCNP Encore, because I'll be quite honest with you, I haven't taken tests yet. I took the old test, but not the new one. So I'm getting ready to retake this one. But one of the things that I noticed is that with the official Cisco training, there's a ton of stuff on wireless. So I want to make sure that you are aware that in the exam objectives, one of the big items here under architecture, 15%, you'll notice one of the entire things is wireless LAN design. Then down here, this is a big one. Infrastructure is 30% of the exam. And there's an entire section that is nothing but wireless. So you've got to know that you understand resultant signal strength, signal noise ratio, interference noise, band and channels, wireless device, what is free path loss, different modes, even looking at a picture of an antenna, knowing, is that an omnidirectional antenna? Is that a Yagi? Is it a directional? What is this? Troubleshooting wireless layer 2, layer 3 roaming. So understanding. And one of the things the book doesn't do a good job of is talk about the concepts of point of presence versus point of attachment. So make sure you look those terms up. So point of attachment is the AP you're connected to. Point of presence is where you are actually connected in terms of layer 3 connectivity, VLAN. So it is possible to actually roam from one AP to another AP, change your point of attachment to a different access point, but a cap-WAP tunnel is continued back to your old AP so that you keep your point of presence. So in other words, you can roam from one AP to another AP, and that AP may not even support the VLAN you're on because you're connected back to a cap-WAP tunnel at layer 3. So those types of concepts you need to be aware of, and that's something that's only lightly covered. And I went back through all of our different chapters here. So we've got it, in the Encore book on chapter 17 is an entire chapter on wireless. Know that 0 dB is referenced, and then 3 dB plus 3 dB is 50% more power, and then 10 dB is 100 times more power, or 10 times more power, not 100, 10 times more power. Minus 3 dB is half power, minus 10 dB is 1/10 power. And then all those are references of one another. Know what it means to be out of phase and in phase. So think about this: if if two signals are 180 degrees out of phase with each other, they're going to cancel each other out because they're diametrically opposite. So they're actually going to cancel each other out. That's how you get noise canceling headphones. Let's see here. The powers of 2s and 3s, or 3s and 10s, excuse me, powers of 3s and 10s. Anytime you raise it by 3 dB, it means the power doubles. If you raise it by 10, it goes up 10 times the reference value. And this is, by the way, very confusing when you look at this. But one of the things to know is that we measure this, it's logarithmic. Yeah, I think I said that right. In other words, it goes up exponentially pretty much. A logarithmic function. So it's very confusing when you look here, but we really don't have to know all of that. We just have to know basic ideas, and that is 0 dB is your reference power, be where you're starting. If you want to have 2 times the power, you go to 3 dB. If you want 10 times the power, you go to 10 dB plus 10 dB. Half power is minus 3 dB, 1/10 power is minus 10. All right, so all that's in here, so you can kind of look at that. The free space path loss is normal loss of a signal as it travels out from a source, and that is what is considered when there's nothing in the way. So you're going to have loss regardless. And the best example I've seen and heard of this is if you throw a rock out in the middle of a lake, you'll see there's a very close to where the rock hits, you've got very close wavelengths and signals, and as it goes out, the wave gets smaller and smaller. So that's free space path loss. Our other chapters talk a little bit about our concepts of cap-WAP and those types of things, but make sure you spend time knowing wireless because it is on the exam. And I don't want you to get caught by that. The assessment viewer here, by the way, this is the chapter 17, 18, and 19 exams. Be a good thing to look at this because there's some really good, just like this. When comparing two absolute values, what can a wireless engineer conclude after calculating a result of -3 dB? Well, you've got half of the reference value. So the laws of 3s and 10s you're going to want to know. The other thing I didn't see mentioned in our book really much is Cisco, when we look in here about up here, looking at location services in a wireless LAN. A lot of times they talk about you need at least 3 APs to do good location services, so you can triangulate the client using 3 APs and the resultant signal strength indicators from those APs. There's also a thing called DNA space, which basically looks at your maps that you bring in of your entity and then puts the access points on it and makes a decision about where those access points should go. But Cisco CMX is also one. Mobility experience can be used to help with location analytics. And this can be used for everything from dwell time, how long someone's in a particular area, where they're at in a business, what they're doing in the business. This is a little bit scary because you're really tracking your customers to see what they're doing inside. And then I learned something very interesting. And this was through some study I was doing last night about placing access points. But when you're placing, I'm gonna pull up Cisco whiteboard here as soon as I can get it up and going. Oh, I can't type it. I think I did anyway. Or Microsoft whiteboard, not Cisco, Microsoft. Let me get this up and running and get you in here. It's trying to sign me in here. And of course, it's got to text me because we have multi-factor authentication. So give me just a second. Okay. So last night I was studying about best placement of access points. And of course, I know there is very much it's more of an art than a science in a lot of ways. But for location services, one of the things it talked about is this. By the way, I got a whole lot of different whiteboards here. But imagine you had a building and that building was shaped as follows. So let's imagine the building was shaped like this. So it was basically a long rectangle. For location services, where do you think you would put the access points? Where would be the best place to put them? What's the recommendation? Where would you put access points if you were doing this building?
Well, it depends on what's going on in there.
A lot of that is, and a lot of us would think the best thing to do would be to put access points in the middle, right?
Well, it all depends on the size of the building as well, because if you're gonna if it's a large open building, you may put, well, yeah, depending on how wide it is, you may put the patch panels on the outside and have it facing the middle.
Yep.
And you may have to do that on either side. Is this a warehouse? Do you have a whole bunch of shelving? Is there vertical interference? You have to look at that as well.
Definitely.
Are there rooms? There's a lot of things you got to look at.
Definitely. One of the things it talked about though is if you're trying to do like location services, you're better off doing this type of thing where these overlap like this.
Mm-hmm.
So that, and then obviously you're going to make it big enough. There's no this. You're going to make sure that doesn't exist, obviously.
Well, if it did exist, you would probably just drop something from the ceiling.
Right, exactly. But the idea is with location services, they were actually suggesting you put the APs on the outside walls like this on long rectangular rooms or long rectangular buildings that have no interference in the middle, like you're talking about, Corey. Now, if the building's a bit too big and you can't get them to overlap completely right here, then you're going to have to put an AP here, an AP out here, obviously. But that was interesting, I thought, for location services, that they considered this to be better, because the reason you want this is hopefully you're going to make these to where all of these overlap enough to where a client can be seen by 3 different APs all at the same time. And then you'll be able to measure that and kind of get a location based upon resultant signal strength. So I thought that was kind of interesting, kind of cool. Something I had never really thought a whole lot about. I do know that when you're doing wireless placement, a lot of it is you've just got to do a site survey. You've got to walk around. You've got to walk around with the APs and put test APs in, look at the signal strength and those types of things. Because the other thing you got to realize here, if this is a warehouse, what is out here? You know, what are you giving access to all the way out here? Plus, another thing we talk about in these wireless sections are your antennas and their the way you point your antennas to ensure that you've got the correct size and shape for your reception range. Okay, so your polarity on the antennas themselves. So you have to be careful with that. But I thought that was pretty interesting when I was looking at that the other night. But notice how we've got, and I was kind of getting a little frustrated because like, man, I'm reading a whole lot of wireless stuff. Then I went back and looked at the these overall items. You've got wireless, you've got an entire section on wireless, and one of the biggest items you've got here, an entire section down here on troubleshooting, configuring EAP and WebAuth and PSK, pre-shared keys. So wireless shows up over and over and over. So we need to make sure that we're comfortable with those concepts as you're working in here. So make sure you're reviewing these chapter 17, chapter 18, chapter 19, and you know the standards. One of the things I was having trouble is remembering which one supported only 2.4 gigahertz for some stupid reason. And I figured out the BGs. The BGs support only 2.4 gigahertz. So B and G support 2.4. A and N, A and AX only support 5, and then you've got N and AX. A and AC only support 5.5 gigahertz, and N and AX or NAX support both 5 and 2.4. And then of course we've also got even newer standards out now, that Wi-Fi 6, which, unless I'm mistaken, and tell me if I'm wrong, but Wi-Fi 6 and 5G are really basically the same standard.
No,
they're not.
5G is cellular. Wi-Fi 6 is the AX standard, and Wi-Fi 7 is 5G is just the 5th generation of the wireless network, whereas Wi-Fi 6 is the newest standard. When the newest IEEE 802.11 standard comes out, that's going to be Wi-Fi 7.
I swear I read something about 5G being very close to Wi-Fi 6.
It may move traffic at the same speeds. It's still, I think it's protocols are similar.
I did learn something this week that has just happened in our area. They've turned off the 3G networks. So there's no more 3G networks. So the drink machine in our building won't accept credit cards anymore because it's only got a 3G modem on it. So that was interesting. So we've only got 4G and 5G. But make sure that you are aware of those items. The spatial multiplexing was a question that came up on the chapter exam, talking about using multiple channels, just multiplexing across multiple channels. Operate on the same channel, but across multiple chains, radio chains.
Yeah, that was, I always wondered how they increased the throughput on the newer standards. And when I was reading through some certification material for wireless, it was talking about multiple streams.
Yep.
X number of transmit, X number of receive, and having all those radio chains and doing it that way. And that's how you can get about almost 7 gigs per second with AX, is through using 8 chains.
8 chains with 8 different radios using the same channel, but 8 different radios working together to do spatial multiplexing.
Yep.
Cool.
So,
really,
but most handheld devices are only going to use about 2 radios because power consumption. They're doing a balancing act between power consumption and power preservation and power consumption.
Right. That's interesting because one of the things I'm going to Argentina this summer for a combo dove duck hunt. I'm looking forward to it. But I was trying to, a couple of years ago, I went to Germany and I took I was in Leipzig, Germany, and I had an Android tablet. and my tablet would not work there because they were using different channels. They were using up to channel 13. You know, we only use like channel 11 through 11 channels, but they use 13 channels. But now the iPad would work. So I had an iPad that would work there, but this wouldn't. So I was like, well, I wonder if my phone, my Google Pixel, is going to work in Argentina, because of the fact, you know, what are their Wi-Fi standards there, which they should be the same. But that was something I ran into in Leipzig several years ago.
And that's just a whatever access point you were logging into. It was set to that channel, not that it couldn't have been changed to one of the other channels.
Exactly. It was set up on 13, and my tablet couldn't get there.
Yeah.
So that was interesting. So, but it was funny because I was like, well, why in the world is yours connected and mine won't? And we figured out that that particular version of the Android tablet I had didn't have those channels turned on the radio. It was set to only be available the US bands, which was very interesting too, because I did read last night, one of the things you can do is access points actually that Cisco make, most of them ship with the ability to be used in any region. But when you connect to it, and you can even connect to it with a cell phone, it will use the geolocation data from that phone to automatically link to that access point. And then the access point will then use that data to set itself to that region to make sure it's abiding by the laws in that region.
And there's also a function, and I want to say it's at 5G, where if it detects radar signals, like around airports,
right?
There's a certain radar band that operates or can operate in the 5G band that we use.
Right.
So if the wireless device, the access point, detects those signals, it will automatically switch to a different channel.
That's really neat. Now, the other thing here, when we talk about looking at describing up here at the top, describing different models, centralized, distributed, controllerless, controller-based, that is chapter 18. And notice these are, the old method was autonomous APs that we had to go to and configure every single one of them by themselves, and they didn't really understand one another well, and handoff between AP to AP when you're roaming was not very efficient. We now have under Cisco WLCs or wireless LAN controllers, and those wireless LAN controllers typically do any of the non real-time features that devices need. Is called split MAC functionality. So the AP still does anything that needs real-time interaction with the client device, but anything that's not real-time is pretty much handled up on the WLC. And they develop, or they take a CAPWAP tunnel, which is controller access point controller. I always forget what CAPWAP is. It's basically controller access wireless AP. It's basically the ability to tunnel back to the wireless LAN controller and have the wireless LAN controller be the main brains of the operation. And then Cisco even has the ability to put these into mobility groups, so that mobility groups can even understand all the clients that are connected to APs in a mobility group. So if you happen to switch from an AP that's on the same controller, it's called intra-controllers handoff. Or if you go an inter-controller, if you go to another WLC or another wireless LAN controller, if it's in the same mobility group, you'll never even know it. You just get handed off, and everything is hunky-dory for the client. It's all handled in the background by the WLC. And in this, we typically use the lightweight access points, so they're not quite as intelligent as the full. Sometimes we call them full access point or autonomous APs, or what we really call them, autonomous APs. And really, most APs that you buy from Cisco can be either, you can set them in either mode. You can make them autonomous, or you can make them lightweight. If you buy them lightweight only, you realize they cannot be used in autonomous mode. You've got to have a wireless LAN controller to make them useful. So that kind of gets into that there. The one thing, this is something interesting that I didn't know a whole lot about, but embedded wireless LAN controllers, say down on an access level switch, and even an embedded wireless LAN controller called Mobility Express WLC, which is in the AP itself. It can do some of the functions of a wireless LAN controller, but it doesn't have all the abilities of a wireless LAN controller. In a full wireless LAN controller environment, they can control up to about 6,000 APs. But you notice this Mobility Express can only do about 100 APs. And that would probably be pushing it pretty good. You may want to know about the fact that when an AP boots, it's going to try to do a discovery, broadcast out, define. It looks for a primary, secondary, tertiary access point, or excuse me, wireless LAN controller. If it doesn't find that, then it looks for a master. If you can't find a master, then it's going to look for the least loaded. And you can actually even, in fact, there's a couple other ways that the AP can find it. If it doesn't see it on boot, then via DHCP, you can actually hand it a DHCP option, which will send it to where the wireless LAN controller is. Or you can have the AP even look in DNS to find a special DNS information, which is called Cisco CatWap controller.local domain. So there's a couple ways. First, it can just broadcast a CatWap discovery. It can actually be primed or set to look for a primary, secondary, and tertiary. Or you can use the DHCP option 43, which gives it a list of wireless LAN controllers to go to. And then last but not least, it can just take DNS and try to find a controller that's been given, or a set of controllers that may be given this DNS entry information. If it doesn't find any of them, well, then it just keeps doing the discovery process. Especially if it's a lightweight AP, it won't be able to boot until it finds a wireless LAN controller. You may have to, if an AP and a controller on a different subnet, since that broadcast does use UDP and it's to port 5246, you may have to set up the router to forward that particular command or that particular broadcast to the wireless LAN controller. So you may have to ask it, say IP4 protocol UDP 5246, and then by using the helper address, that will have it forward anything that is set up in the forward protocol list to that IP address or to the IP address of the wireless LAN controller. So you do your primary and secondary wireless LAN controllers as a helper address. All right, so APs do check their wireless LAN controller every 30 seconds. If that's by default, if it finds it fails, it can actually then look and move over to a secondary if you have one available. There's even a special thing called wireless LAN controller staple switchover redundancy, to where you have a wireless LAN controller connected over a special link to another wireless LAN controller that is containing a full stateful database table of all the clients on a wireless LAN controller. So if this one dies, it immediately switches over to the other one with absolutely no downtime for your clients. All right, any questions on that? I won't spend much more time on this last one, but you definitely need to go over this last one, the 19, because it gets into wireless roaming. And this is where I was talking about the difference between autonomous AP roaming and getting into roaming between intra-controller roaming. So basically the CatWap tunnel. When this happens, your point of presence stays the same, your point of attachment changes. And then where was that? Here it is, being able to roam between a centralized controller and inter-controller roaming, which is when you go between one controller and another. This is where you may actually end up with a point of presence to an AP controlled by another wireless LAN controller. So your point of attachment may be here, but your point of presence may be over to this other wireless LAN controller. Because imagine that this domain or this subnet 100 staff doesn't exist over here for some reason. If that would be true, then you'd have to go all the way back over here. In this case, it does exist. But if it did not, you would have to actually establish your CatWap tunnel back over to the WILC 1. Okay, so here's that concept. Layer 3 roaming. So he moves over, so your point of presence changes, okay? Or excuse me, point of attachment changes. So you're now controlled on a different AP with a foreign controller that is not on VLAN 100. So there has to be a CatWap tunnel built all the way back to this controller so that your traffic will be on VLAN 100. So this is layer 3 roaming. Up here is more layer 2 roaming, because you're still staying on VLAN 100 when you go over this other we'll see. Here's your mobility groups. And you can even have mobility domains with up to 3 mobility groups that can all share information, so you can wirelessly roam. You have to have a pretty big campus to need this to be able to wirelessly roam, but it is possible to do it. And again, your resultant signal strength can be used to determine location. If it's a single AP, it's going to be very difficult to get very close. It's like something like 20 meters is the best you can do with a single AP. With 3 APs, I think you can get within like 5 meters of location. You can actually get within, I think, 1 meter if you turn on special I think it's hyperlocation services in the AP, which turns on the hyperlocation plus Bluetooth, and it uses both Bluetooth and hyperlocation services to find out where the wireless client is. So this DNA spaces is a special thing that lets you basically have a floor plan that you load in the DNA center, and you can look and see clients on that and get an approximation of where they are on your in your network for real-time data and tracking. Which on most buildings like this, it wouldn't matter, but imagine if you were a business and you were trying to track, let's say, like, for a great example would be a mall that gives away free wireless access. Try to track, how do people get to the food court? Where do they go after they leave the food court? If people are going to the movies, how do they come in, so that you can place advertisements in specific areas to try to attract people? Which we're moving into the world. If you've ever seen, oh goodness, Altered Carbon, the sci-fi show, where basically as you walk around, the billboards change based on who you are. And they advertise things to you. We're really moving into that type of world, believe it or not, which is kind of scary, to be honest. But that's really all I had today. I just wanted to make you aware there's a great deal of wireless on the exam objectives. There's a great deal of wireless inside of those chapter 17, 18, 19. So make sure you spend time looking at those and making sure you understand how all those items work, because it's going to be on the exam. And one of the reasons this exam has really been a thorn in some ways, but you have to understand, one of the big things about this is, to be a CCNP, everybody takes this. So this is encompassing all the other concentrations. So we're going to take ENA-RSI this summer, so we're going to concentrate on the routing side, but you may be going to the wireless. And so that's why this exam has to, the base exam, this ENCORE, has both in it routing, SD-WAN, enterprise, wireless networks. It's got all of those because it's trying to encompass all those items as a base exam before you move into your specialization, which is good and bad. Like I said, the bad news is, it is a $400 exam, which is extremely expensive. All right, any questions?
I'm good.
All right, I'm gonna stop.